All right, so we're going to move on to talk about the different kinds of statistical relationships here. So when we're talking about a statistical relationship, what I want you to think about is it's something that should be thought of as a trend. So it's not necessarily deterministic or showing that it's a causal relationship. Really, that's not what we're talking about with statistical relationships. When we are looking at them, though, there's different ways we can describe each of those relationships. So the first way we might describe it is with something called a D relationship. When you have a D relationship, what I want you to think about is there's two different groups. So we might be looking at something like the difference between men and women in some variable. And I'll show you an example of that as we get further into what a D relationship actually is. When we're talking about an R relationship, which is our other type of statistical relationship, we're talking about one variable that's going to differ across levels of another variable. So we can even predict what one variable might be based on that first number. So if I said your shoe size is X, I could be able to predict with some accuracy how tall you might be because those two things are related. So when we're talking about a D relationship, we have groups. When we're talking about an R relationship, we have two different numbered variables and they're related to one another in some way. When we talk about these relationships, I think it can be really helpful to have different examples. So that's what we're going to talk about right now. The statistical relationship between IQ and academic performance is one that's really easy for people to just generally and conceptually understand, right? People who have higher levels of IQ generally tend to do better in school, right? That generally makes sense. Is that always the case though? No, absolutely not. And this is why it's not causal. So when we're talking about statistical relationships, remember, keep in mind, these things aren't causal. It generally works this way, but it doesn't always work this way. Another one that might be helpful for you to understand is alcohol consumption and blood alcohol content, because these two things sound very similar. If you drink alcohol, you are going to have a higher blood alcohol content because the alcohol is in your system. Right? These things go hand in hand, and that's what we're looking at with statistical relationships. So circling back to the D relationship, when we are looking at a D relationship, as I said before, we're looking at the difference between two groups. So we have one categorical variable and one continuous variable. Right? So in this graph that you can see here, you can see that there's a difference between men and women and how they scored on some variable. This variable could be anything in terms of height, right? Men generally tend to be taller. Are all men taller than all women? Absolutely not. But generally that tends to be the case, and we can see that depicted in a D relationship. It shows how there is a difference between these two groups. A few other examples of D relationships that might be helpful are things like, are women more talkative than men? When we're looking at this, again, with the men and women, we can clearly see our two groups. Our categorical variable here would be sex. We have group A, which would be women, group B, which would be men, and we would rate them in terms of how talkative they are. And there's a lot of different ways that we could even measure talkativeness, right? We could count the number of words per day that these people might use. Or we could ask them to rate themselves on a scale of 1 to 10. How talkative do you think you are? Whatever it is, we're going to collect some numbered variable and then apply those to the two groups. That's what we're looking at when we see D relationships. So now we're going to talk about R relationships. And when you think about an R relationship, what I want you to remember is that we have two continuous variables. In other words, two numbered variables. We're going to take those variables and compare them to one another. So as you can see from the graph here, we have stress and physical symptoms. So the more stressed a person tends to be, we can see that their physical symptoms actually increase. This lets us know that there is a relationship between how stressed out someone is and how poorly or how many physical symptoms they're going to start to experience. It's important that you know that when we're talking about Pearson's R, unlike Cohen's D or D relationships, we have to consider the direction of the relationship. So it may be positive, in other words, as one thing goes up, the other thing goes up, or as one variable goes up, the other variable goes up, and negative relationships. As one variable goes up, the other variable goes down. we always need to differentiate within our relationship, is it positive or negative? This tells us a lot of information about how these two continuous variables are related to one another. As you can see from these graphs, when we're talking about our relationships, we determine how strong the relationship is based on the way that the data relates to one another. In other words, how strongly correlated is one variable with another. This is going to range from a positive one to a negative one. With a positive one, as it should suggest, we're talking about a positive relationship. With negative or negative one, we're talking about a negative relationship. Again, as one goes up, the other goes down, versus positive, as one goes up, the other goes up. You can have a zero relationship strength when we're talking about our relationships, and essentially there's no correlation between the data points at that level. Anything from 1 to negative 1 can be what we represent Pearson's R with. Anything beyond that wouldn't really work because nothing can be more perfectly correlated than 100%. It doesn't make sense. Let me give you an example of an R relationship to maybe put it in a better context for you. When you think about the amount of time someone plays a violent video game, right, we generally see that there is an association with higher levels of aggressive behavior. And so we can see that the amount of time, a numbered variable, correlates with the number of aggressive behaviors or how aggressive that person is. We can then correlate these things together to produce a graph that will depict what this relationship actually looks like. And so you heard me mentioning how we quantify these relationships, whether it's -1 to 1, perfectly negatively correlated to perfectly positively correlated. Let's look at a couple of different ways in which we show these relationships. For both Pearson's R and Cohen's D, we have something we like to call relationship strengths. This is a helpful way for us to determine how strongly two things are correlated, whether it's a Pearson's R correlation or a Cohen's D correlation. So when you're thinking of Cohen's D, right, remember we have two groups, and we have one continuous variable. We're going to have three different categories. The first of which is a weak or small correlation, and that is at 0.2. We then have a medium correlation at 0.5, and a strong or large correlation at 0.8. For Pearson's R, it's similar, but a little bit different, and this can be confusing, so I suggest that you spend some time to really memorize these different values. They'll be useful throughout the entire course. With Pearson's R, we say that we have a weak or small relationship when we're at 0.1. We say that we have a medium relationship at 0.3 and a strong or large relationship at 0.5. For Pearson's R, it can be helpful to think about it in terms of the first several odd numbers, 1, 3, 5, 0.1, 0.3, 0.5. May make it a little easier as you're trying to memorize these.